domain and range?
Um, so we did, so it's like domain is all real numbers and range is y is less than -1.
Okay, so you're using set builder notation, that's fine. So so you're right. So the domain for all of these is always going to be all real numbers, okay? All real numbers.
Okay.
The range depends on whether it opens up or down, okay?
Okay.
So if it opens down like you've got here, it is like you said, and in set builder notation, it's y such that y is an element of the real numbers, comma, y less than or equal to, and what goes next, what goes in this position here is the um, y value of the vertex.
Okay.
Okay. If it opens up, it's y such that y is an element of the real numbers, comma, y greater than or equal to, same thing, it's the y value of the vertex.
Okay.
Okay. Any questions on that?
No, I
Yep,
understand that.
we got that part's down. Okay.
Yep.
So the next thing to look at are transformations. That's kind of 5 through 12. Okay. So so let's look at, like, for example, number 5. And have you ever used Desmos for graphing?
So I have a graphing calculator, but I don't really use it that much.
Okay, so what I'm asking about is something on the computer. Um, it's really helpful for homework stuff. It's a tool. It's a good thing. All right. I'd like to
Okay.
just show you that real quick. Maybe you've seen that before. Just give me a moment here to get that up here, and then I'll
Okay.
share that screen. So it's called the Desmos graphing calculator. I'll drop it in the chat, but I'll also share that in the screen with you. So I'm going to new share that real quick. Okay. Have you seen this before?
Yes, they have those on like the tests that I do.
Yes, that's right.
Yeah.
Now, we'll go through how to do it on your calculator at some point, but this is such a better tool. This is like using your phone versus using, I don't know, something else, a phone book or something. It's like way better. Okay. So the,
Okay.
the, the y equals x squared is called the parent function. Did you talk about it in the class, and do you have any idea what
Yeah.
that,
Parent
that
function.
means?
Yeah.
Yeah. Okay. All right.
Isn't it like you either have a like some the other function is a spin-off of the parent function. So
Exactly. It's like you look like your parents, to some degree you look like your mom and your dad, some combination of them. That's kind of the best analogy for that.
so
Okay.
like the 6, wouldn't it be like a vertical shrink or a vertical or
This
a
one's this one's a vertical stretch.
vertical stretch?
Okay. And we'll talk about why that is without having to graph it, but this tool makes it very easy for you to uh, graph multiple functions. So, like, let's say I wanted you to look at y equals 1/6 x squared. How does that one compare to the original?
It's wider.
It's wider, and the other one is narrower.
Yep.
Okay. Now let's do something else here. What does putting a negative in front do?
Flips it.
Now you got to be careful. You got to express which axis. It flips over the,
X-axis.
yes. Okay. And you can do more than one thing. So you can, for example, see how the 6x squared is narrower and then negate it, and it flips.
Yeah.
Okay. So let me go back to the other screen, and we'll just try to summarize here. So this problem is in this form. It's of this form as ax squared. Okay. So if a is greater than 1, okay, you say that it's a vertical stretch by a factor of a. So in your problem, you would say vertical stretch by a factor of 6. Now, some
Okay.
teachers will let you get away with just saying vertical stretch by 6. you're in an honors class, I would try to go for, the full information.
Okay.
All right.
Okay.
Any questions on that before we look at another, one in that section there?
No.
Okay, so 8 is 0.75 x squared. Okay, so this is a vertical, no longer a stretch, it's a
Shrink.
shrink. Now we take that to mean wider, but they want certain words. Okay, so this one, and you by a factor of, and this word gets a little tricky. We'll just say 0.75 for now. If you saw something in class, please let me know. But the language is really important. It's almost like an English class now where the words really do matter. Okay.
Okay.
And then a problem like, for example, like 10 is minus 9/2 x squared. There's two things going on here. Okay. And the order does matter, but these actually are kind of equal precedence. So 9/2, it's greater than 1. So forget about the negative for a moment, just the
Okay.
number. Since 9/2 is greater than 1, we would say a vertical stretch by 9/2.
And then it would be a reflection of the
Reflection, yes,
x-axis.
exactly. And you have to give all of that. You can't skip out on any of those words. They're very important here.
Okay.
All right.
Huh.
So any questions on that? Because that kind of covers 5 through 12.
Okay.
Actually, I guess and 13 through 16 are kind of similar to that. They're really trying to get you to understand this whole idea of the A in front.
Okay.
So let me just be clear here. A equals, A is the number in front, the number in front. All right. And the idea is there's possible cases for A. So like A greater than 1, that's like 6x squared.
Okay.
A can be between 0 and 1. That's like 1/2 x squared. And we've talked about both of those. This is a vertical stretch. This is a vertical shrink. Okay.
Okay.
But then what if A is between -1 and 0? So like -1/3 x squared. So now this has two things going on. It's a shrink again,
Yeah, it's a
vertical
shrink
shrink,
and
and
a
it's a flip.
reflection.
Yeah, or reflection. Better word than that. Better to use reflection than flip. And then the other possibility is if A is less than -1, like -5 x squared, it's a stretch and a reflection. So you have to know all of these, among others. This is only part of it, but this is what they're asking you to be able to be able to go between.
Okay.
Any questions on that or anything sort of to follow up with?
No, I understand that.
Okay, very good. All right. So like, are there other problems in this assignment that you would like us to cover?
So, one of the ones was describing a graph, and there's several like different ways you're supposed to. Um,
Do you have an example of a problem like that?
so, yeah, I do.
Is that in the new stuff you sent over or
It's in both.
okay.
So, for instance,
Like I'm tempted to just say, let's go to the second, set of pictures you sent to try to get some more clarity
yeah,
on
that
this.
might be better.
Okay, so we'll start with exploration 1.
Okay.
Is that okay?
Yep.
All right. All right, so here is exploration number one. I know you got it in front of you. So visually, what is the difference between the two of them? Like, what does one have or what does one lack that the other has or doesn't have?
Y. Oh, +6.
The +6, okay. So I'm going to go back to that other tool, and this is just to help with the graphing part of it. And you can clear out your old graphs on the right here. Sometimes you keep them, sometimes you don't. So we're going to graph y equals 2x squared minus 8x, okay? Now let's look at some of the things here that might be of interest. And this is why I really like this Desmos. You can click, get the points. It's a little harder on your graphing calculator. You gotta do a few other things to get there. These are the x-intercepts. This is the vertex. This also happens to be the y-intercept, okay? You can also use copy and paste. So I'm copying and pasting and adding a 6. What do you notice about the vertex? What happened with the vertex?
It translated down.
So the red is if we consider the red the
Oh,
original,
the red's the parent function.
well, they need kind of neither, but like you got just, from which one to which one. Yeah, it either went down from the blue to the red, but it went up 6 or down 6, right?
Yeah.
It also interestingly impacted the x-intercepts, okay? So but let's look at this question by question here, and I guess we'll keep this up for now. It says, what do you notice? And I guess you do need to sketch this. So let me snip this in to the other window. Do you have to turn this in typically? Okay. All right. Well, what they're looking for is two curves, where one is a little taller than the other. But in terms of what do you notice about the x coordinate of the vertex, you're supposed to say, oh, it's 6 up or it's 6 down, depending on which one you're talking about. Is that okay? Is that clear?
Yeah.
All right. All right. Now part C, we can do by hand. So I'm going to jump back to the other window. Jumping around a little bit here. Hopefully that's okay.
Yeah, that's fine.
All right. Okay. So there's kind of some really key here that they're telling you that might go over your head if because there's so much going on. So it's new, it's fresh. An x-intercept, just like with lines, it means that y equals 0. That's why in the second line, it tells you what you're solving. It's saying solve 0 equals 2x squared minus 8x. They're saying put 0 in for y. Okay.
Okay.
And then solve. Okay.
Okay.
So this is why you learned your stuff from your previous section. You have to know how to factor this. All right.
Okay.
So you have to, this is a GCF. What is the GCF here?
Um,
On the right.
2x.
2x, yeah. And so this becomes x minus 4. Now I always move the equal sign over here to the right, sort of more common. And you set each term equal to 0.
Okay. And then you get x equals 0 and x equals 4.
You got it. Yeah. Okay. Now, what does that mean? What does even that mean? Well, let's go back and look at the graph. Okay. So that's for the one in red. Sorry,
Yeah.
maybe you're going to answer me, but
Those
those are the
x-intercept, right?
exactly. That's what that means. Yes. Okay. So that's for that one. Now, we might as well talk about how you do it for the other one, the other equation. So the other equation was or is 2x squared minus 8x plus 6. But again, it's a y equals, right? So if you want the x-intercepts, you have to set y equal 0. So you write 0 equals 2x squared minus 8x plus 6. I'm going to put the 0 over here. What is the first type of factoring you should always do?
Greatest common factor.
and this has one. Okay, it makes it much easier if you do it this way.
Okay.
All right, now can you factor this for me?
3x has to multiply to 3x squared, add up to -4. So I think it's -3x and -x.
So it's just the last number. You're looking for two numbers that multiply to 3 but add up to -4. And you said the right numbers, but it's x and then x here.
Yeah, so x minus 3 and x minus 1.
Good. Now you only set, very important, you only set x terms equal
Yeah.
to 0. That 2 is not an x term, it's a constant. It's irrelevant. Only the x terms, right? So
Okay.
x minus 3 equals 0, x minus 1 equals 0.
So then x equals 1 and x equals 3.
Yes. Now let's go back up and look at that on the graph. Okay. Is that consistent with the blue?
Yeah.
It is. And it's supposed to be. It's absolutely supposed to be. Okay.
Okay.
Which means that the graph and doing it by hand give you the same information.
Okay.
Anything about that unclear?
No.
Okay. So you find x-intercepts, and I guess I don't know why they're having you do it this way, but they're telling you that you find x-intercepts by setting it equal to 0.
Yeah.
Okay, this is all weird. Can I jump to just 4, a problem like 4, and I guess go through all the things? Well, or maybe
Yeah.
the okay. All right. Sorry, there's a certain way to teach this. When I jump into the middle of it, it's not as good as if it was just fresh here. So let me just reset here a little bit. So here's what's going to happen, Braeden. You're going to be given an equation, okay?
Okay.
And you have to, the first kind of fork. You already learned systems of equations, I believe. And remember, there was like 2 forks. You had to decide whether you use like substitution or elimination,
Yeah.
or even graphing. Well, here you have to notice if it's in what's called standard form.
Or
This is
y-intercept form or
vertex form.
yeah.
Okay, and it's like some things are more obvious in one form versus another. Okay, so your class has chosen to present to you standard form first.
Yeah.
Okay. All right. So we're like every quadratic problem you see, you first need to recognize standard form or vertex form. Okay. This one is in standard form. Okay. So a is the coefficient in front of x squared, b is the coefficient in front of x, and c is the constant. Can you tell me a, b, and c for this problem?
3, -2, and 0.
Very good. Okay. Now there's kind of like, and I don't have room for this, but there's like, for finding the vertex, it depends which branch you're going down, how you do it. Okay. So the first thing you are going to find, I know it always wants the axis of symmetry, but we're going to actually find the vertex first. Okay. And the vertex comes from formulas when it's in this format. So the first formula is that the x coordinate of the vertex is minus b over 2a.
Yeah, that's what I was taught, was the minus b over 2a.
Okay. So this is 2 over 6, or 1/3.
Yep.
Okay. Now, to find the y coordinate of the vertex, this is where it gets harder. You have
You have to
to
plug 1/3 back in.
exactly substitute the x back in. So this one's awful. It's fractions squared. Nobody likes. I don't like these. But it's 3 times 1/9 minus 2/3. So it ends up being 1/3 minus 2/3, which is minus 1/3. Is that okay?
Yeah. I just plug, so usually if I have like a fraction like that, I'll like plug in minus for like 1/3, I'll just plug in 0.33 and then understand that it's going to be a never ending answer.
Okay, so just as review though, 1/3 squared means two things. It means 1/3 times 1/3.
Yeah, I'll plug it into like a calculator. So
Okay.
0.33 squared.
You really don't want to do that because there's like this is an approximation to the exact. You're a math student that needs to be doing it exactly.
Okay.
And we can spend some time talking about that if you need, but I would strongly encourage you to avoid doing what you just said. Like, and I know that's probably really uncomfortable. Um, we maybe should spend some time using a calculator to show you how to kind of navigate that a little bit, but
Okay.
um, this is going to cause you problems down the road.
Okay.
Okay. But nevertheless, what you have to do is summarize and say the vertex is whatever it is. It's 1/3 comma minus
Negative
1/3.
1/3.
Okay. Now, the axis of symmetry is always x equals, it's an equation of a line. It's x equals, and it's the x coordinate of the vertex.
So then x equals 1/3.
Yes. Now, we're going to go back to Desmos and look at this thing graphically because you need to know why, like, why are we doing all this? What does it actually mean graphically? So let me go share that and graph the equation again. So this was y equals 3x squared minus 2x. Now, the Desmos does not do a good job with fractions. Like it uses decimals. So you have to know that that's 1/3 minus 1/3. Now your axis of symmetry is x equals 1/3. Okay. This line, this vertical line goes through the vertex. Do you see that? It goes through the vertex.
Yep.
And it furthermore, more importantly, it divides. It's like a mirror. It's the left side reflects to the right side, or the right side reflects to the left side. Is that
Okay.
okay? Is that, does it give it
Yeah.
some meaning? All right. Okay, so let's go back to the other screen and have you try a problem here. I want you to try number 2
Number
in
two.
the
Okay.
monitoring progress. I'll snip it in. I
Yep.
want you to find both the vertex and the axis of symmetry. And I just want your final answers. So um, when I say that, what I mean is, like, imagine I'm only grading a box that's for your vertex and for your axis of symmetry. Like, just tell me what goes in there when you're all done. But if you have questions, please ask.
And what do I do with the C? So for number
Nothing.
2, there's a C. I just don't do anything with C.
It doesn't. So the formula is minus b over 2a. Okay.
Okay.
So you don't need C, but you need C to find the y value of the vertex.
Okay. Negative times 6 over 2 times 1. X equals negative 3. Nine plus 9 minus 18 plus 5. Minus 9 plus 5. So for my 2 points, I got x equals negative 3 and x equals 4. And then for the um, axis, or for that line of symmetry, I got x equals negative 3.
Okay. So those sound correct. Let me, though, here's what I was looking for. I'm looking for an ordered pair for the vertex and an equation
Yeah.
for the axis of symmetry.
Yeah.
So if you got -3, and then I think you said, what did you say for the vertex?
Negative 3 and 4.
Yeah, yes, that looks right. Then you're correct. Okay. Very good. So the next thing, and this is a good problem to do that in, is and there's this whole list. Okay, like, let me scroll back up here. There's this whole list, like there's vertex, there's axis of symmetry, there is, like, we'll do this next, domain and range. Okay, we kind of already talked about that, but the range is the key. Okay, now do you know if this parabola opens up or down? And it's based on the value of a.
Yeah. So it's up because
It
it's
opens up,
positive.
right? So that helps you to determine the range. The range is y such that y is an element of the real numbers. Y is greater than or equal to, and it's always the y value of the vertex.
Okay.
All right, so can you give me that value? I'm just kind of sorry, I'm kind of waiting to see if you would jump in there or not.
1. Y is greater than or equal to 1.
So we're looking for it's got to be the y value of the vertex. What's the
Oh.
y value of the vertex?
Y 4.
Yes. Okay. Now the domain, you're really supposed to write in set builder notation x such that x is an element of the real numbers. This means all real numbers. And if you don't understand it, like I didn't understand it either, you probably won't understand it until you take a class in set theory, if you ever do. But you just got to know how to write it. You got to say, okay, yeah. Okay, so that takes care of that problem. Now, the next thing we can do, again, it's like a super long list. You can find the y-intercept. So the y-intercept is when x equals 0.
So
And
then would I set g of x equal to 0?
no,
then...
no. So let me actually put these side by side. The x-intercept is when y equals 0. That's what you just said.
Oh.
So
So then do
there's
I
two.
set all of the x's in that equation to 0?
Yes. So on the left here, you replace x with 0. On the right is when you set the g of x to 0.
Okay. So then the y-intercept would be 5.
Yes. And it's an ordered pair. Okay. It's like 0, comma,
So
5.
5. Yeah.
Now on the right, you're setting the equation equal to 0.
Yeah.
And you don't want to mess that up. In this first start. So remember on the right how to factor this? This is a factoring problem.
Okay. So 5x squared has to add to 5x squared, but multiply to 2x to 6x. So it's 2x and 3x. So x plus 3 times x plus 2.
Good. So the kind of the intermediate stuff you said was, yeah, I don't want to be too critical, but this is perfect. This is what I wanted to see.
Okay.
All right. So set each of these equal to 0.
Yep.
Okay. Any questions on that?
No.
A couple other things that they do ask, which is kind of from back up here, whether it opens up or down. Sorry, I'm just trying to see where we start here. So actually before this, I should have asked whether this opens up or down. You already told me it opens up, which means that it has a min. That's another thing they like to ask in these questions here.
Okay.
Okay. So why do you do all this stuff? Because it makes it so that you can graph them. All right. And there's several ways to graph these, but we should do another problem here, maybe start to finish with, finding these values. Now, do you have specific homework problems you need us to get done? I don't want to miss out on doing those if you need certain ones done.
No, I don't think so.
Okay. Your mom and I exchanged a message today. It's something about you having some issues with homework last night. So I'm happy to work on anything you need to help you in this class.
Yep. Okay.
Okay, so let me do this a little bit more programmatically. First thing is does this open up or down?
Up.
Okay, and this means that it has a min or a max.
Max.
So what some students do is they draw it, or you see them in the classroom with their finger tracing it.
Oh yeah.
Okay, and
So
now you
min.
min. It's like, okay, you're like, why are they doing that? It's it's not a Jedi Force trick. It's they're trying to see what they're trying to visualize it. Do
Yep.
that. Okay. Second thing here is to identify, A, B, and C. All right, and you've got those down. Now
Yep.
they can, like, occasionally they'll put these in the wrong order. It's got to be in descending order. X squared, then X, then 1. So I want you to find the X coordinate of the vertex for me, please.
Okay. X equals -4 over 4. X equals -1. Then plug it back in. So then 2 times -1 is -2 minus 4 plus 1. 5. So I got, for the coordinates of the vertex, I got -1, -5.
Okay. So 2 times -1 squared plus 4 times -1 plus 1. So you got 2 minus 4
Oh,
plus
wait,
1.
it's 2. So then it would be -1, -1.
Yeah, -1, -1. Okay. All right. Yeah, and that's, you got to get that down, perfect to start, because it messes up everything else. So your vertex, you got to give it as an ordered pair. So your vertex is -1 comma -1, like that.
Yep.
Okay. So domain, we know the domain is all real numbers. How about the range? What is the range in this case?
Y is greater than -1.
Greater than or equal to -1.
Oh, yeah, greater than or equal to.
And that's because it actually, hits that point.
Yeah.
So and you do need all this other stuff. I mean, don't think you can avoid doing that. Now you just had a test. I'm sorry. Was it recently that you've had a
Yeah, it
test?
was like last Friday we had a
Okay.
test.
So if you can ever get a copy of the test, it helps me to know your teacher's style of questions,
Oh,
to
I
better help
have
you.
a I have a picture of the quizzes, of the quiz that we took.
Yeah, you please send those over by email at some point. I'd be happy to kind of help me to figure out what your teacher emphasizes or doesn't emphasize in their style.
Okay.
All right, so here's where we're at. You have correctly given me, everything so far. What is the axis of symmetry? If you remember in words, what is the axis of symmetry?
Um, oh, it's -1.
It's the x coordinate of the vertex, but
Yeah.
it's an equation. It's an equation.
Oh, so x equals -1.
Yes, and it has to be written this way. You're in an honors class, more is expected of you, things like that. All
Yep.
right. So y-intercept. Can you give me that for this, please?
Um, oh, so I gotta set everything to 0. So 1.
Yes.
Is it
So
always the last term if it's put in order like this? Is it always
yes.
gonna be C?
Yes. So that's one of the shortcuts, but it only works if it's in standard form.
Yep.
All right. So the finding the x-intercepts is really, really hard in this problem, because you need to know some things that you don't quite know yet. Have you covered like completing the square in your classes?
No.
Okay, so you will. Um,
Hmm.
these are unfriendly points. They're decimals that are kind of not great. But that's really good. That's really good that you're able to kind of work through those and give me those answers. I appreciate that. So let's do. Well, we should look at the other one there. Um, Okay. Yeah, let's look at another problem here. Okay, so I want you to give me, I'll give you your list here. I want to know whether this opens up or down and whether it has a min or a max.
Okay.
I want the vertex, axis of symmetry. I want the range.
Okay.
And what else do I want here? I want the y-intercept.
Okay. So it'll open down and it will have a max.
Good.
Um,
Those always go together.
the vertex. So A equals -5, B equals -10. So then negative times -10 over -5 times 2. So then that's 10 over -10 and -1. And then plug it back in. So then -5. So -1 squared is 1. It's -5 minus or plus 10. That's 5 minus 2. It's 3. So then for my vertex points, I got x equals -1 and 3.
Okay, so you got to get you here's a so let's how do I say this? You want to say it this way: the ordered pair -1, 3, or you've got to finish off x equals -1 and then y equals, sorry, my screen's freezing up here, y equals 3. You have to carry it out completely, explicitly. Now I know it's late, maybe just tired here,
Okay.
like that, but that is correct. Okay. What is the axis of symmetry?
X equals -1.
Good.
Then the range is y is less than or equal to -1 because it opens downwards.
It's the y value of the vertex, though.
Oh, so y is less than or equal to 3.
Yes.
And then the y-intercept is -2.
Or give me it as an ordered pair, please.
0, -2.
Good. Okay. Now this one does not have x-intercepts that we can easily find. You'll learn about how to do those in later on in this course.
Okay.
Hopefully. I'm sure. Well, I'm sure I know you will. Okay. Great. Trying to think of like what else. Give me some more feedback. Is there like something else from class that you remember that was really unclear?
No, not really.
Okay.
Um,
Do you normally have book problems? Textbook
yeah,
problems to work on?
usually I would, but I now and I like understand how to do them now. But
Okay.
I can see if I can find some.
Yeah, I'm looking for some other problems. I don't want to go too far, but I do have some ideas for what to do next. So let me jump
Okay.
over to the Desmos again and show you. We're gonna do some more transformations because this is really critical that you understand this. So if you're seeing my screen, that's our parent function. Okay.
Okay.
Okay. So now what does the following, let me do it this way, x minus 3 squared. So just to be clear, you're going from the blue to the green.
Okay.
Okay, what happened? Give me words like it moved
Um,
blank blank or something. Fill those in.
it translated right by 3 units.
So we would say the preferred language is shift right 3 units. Now, does that make sense to you with a -3 that it moves to the right?
Yeah, because it's the opposite.
Okay, so you have seen that. That's good.
Yeah.
All right, now what if it's +4? What do you think will happen?
It'll move to the left and
How many units?
4.
I agree. You can see the vertex has moved left. This has moved right. Good. So let's actually do a couple more here. Let's say it's y equals x squared. All right, but now it's -5. What do you think that will do?
Um, Move it down 5 units.
Yes. All right, so let me, sorry. Yeah, so it moves it down. All right. So now here's where it's like, can you tell me the transformations of something like this before it's graphed? There are two transformations. The order matters though. It's first what's going on in parentheses and then what's going on outside parentheses.
Um, is it gonna move to the right 3 units and then move up 4 units?
Let's take a look here. So where is the new vertex? There it is. It's right 3 units, up 4 units.
Okay.
Okay, let's try another one here. Okay, how about this one here?
Move. Does it say plus or minus?
Oh, sorry, my cursor's there. There it is.
Move to the left 1 and down 5.
Yes, very good. Okay, now we can actually add even more transformations to this. Okay, I can, for example, put a negative in front. All right, and this is where we're going to jump back to the screen, but the order matters. Like, you have to tell me the correct order of these things. You can't just give the 4 of them or the 3 of them. So let me do that. Let me go to the other screen and let's look at a problem here together. So let's look at something like this. Y equals -3 x minus 2 squared plus 1. So there are 1, 2, 3, 4 transformations. The first one comes from the x minus 2. Can you tell me what that is again?
Move to the right 2.
So you'd say shifts right 2 units or shifts right 2. I don't care. You got to get in. Your instructor has a certain language that they like to use. So go with that. Now you kind of have a choice here. You can either do it based on the 3 or the negative. I tend to do it off the 3, but but this is the next one. It's either the 3 or the negative. What does that do for this? We
The
talked about very
negative
first,
3.
just the 3 without the negative, because we did this. That was the first thing we talked about. If the number in front is greater than 1, like, ignore the negative for the moment. It's gone. What does the 3 do? Vertical stretch
Oh yeah,
by a factor
of 3.
of 3. Then the negative. What is the negative?
Vertical shrink.
Try again. It's a flip. It's a flip.
Oh, it's a reflection over the x-axis.
Yeah. Okay. How about the +1?
That moves it up 1 unit.
That's right. So you say up 1 unit.
Yeah.
All right. Good. So let's try another one here. So let's say it's y equals -3/2 x plus 3 squared minus 4. Again, there are 4 transformations. The order does matter.
So then it moves to the right or to the left 3.
Yeah, you get left 3. You can say left 3. Okay.
It's a vertical stretch by 3/2.
Okay, 3/2, good.
Uh, it's a reflection over the x-axis,
Okay, and then
and it moves down 4.
down 4, yeah. Okay, now if you're ever wondering, like, how do I know the order? It's really not that complicated if you know the following. The order is based on evaluating the function or evaluating it. So let's say x was 2.
Okay.
And what would you do first after you put 2 in for x?
Add the parentheses.
You'd add 3. Wouldn't you add 3 first?
Yeah.
And that's the first transformation you make. Okay. Then
Okay.
you'd multiply by the
-3/2.
or the
Wait,
3
wouldn't you do
halves.
the exponent first?
Yeah, you would square it, but that's part of the parent function. But you would then
Okay.
multiply by the 3 halves. That was the vertical stretch.
Stretch. Yep.
Then you'd negate it.
Okay.
Then you would subtract 4.
Okay.
Okay, so the order is really based on what you would do to evaluate it.
Okay. And then your answer would be something squared because you did in fact got the square.
Well, no, you would actually simplify this. You would get 5 squared and minus 3 halves. You're not. I'm not asking you to do that. I was just trying to give you
Oh,
a
okay.
reasoning for this. So we do have to stop here, though. Let me stop the recording here.